Hi, this is Jonathan Kelly. Welcome to my video on OpenStack command line basics. In this video, we're going to be walking through some common OpenStack workflows, including setting up the environment variables, using the built-in CLI help, and things like creating an SSH key pair, modifying glance images, creating Nova flavors, booting and deleting images, etc. The first thing that we're going to talk about are environment variables. All of the OpenStack command line tools are set to look for certain environment variables, and we have these set in this OpenRC file, which is auto-generated by our chef install. This is going to vary based upon your installation method. You may have to set this up manually, but what you're really looking for are these right here: username, password, tenant name, auth URL, and an auth strategy. You can specify all of these in arguments to the command line tools, but that's kind of a pain, especially if you're going to be using them a lot, so it's much easier just to have them set up properly in your environment. So now that we've got those set up, and we can take a look here, we should be able to use our command line tools without having to specify any of that stuff. Just like that. We don't actually have any Nova instances running or anything right now, so nothing is going to return from Nova list. Let's go ahead and take a look at the next item, which is command line help. The command line tools all have pretty good built-in help at this point. You can access by running, for example, Nova help. You'll see it's quite a bit there. At the beginning, you have the usage syntax. These are all optional parameters in the square brackets. Hopefully many of these, as you'll see, are set through environment variables. So Nova, optional stuff, subcommand. They have a list of all the subcommands here. There are quite a few of them. You can see we have some related to adding and managing floating IPs, security groups, aggregates, etc., etc. We're mostly just going to be concerned with images, boot, key pair type commands today, but you can control basically anything that the API lets you do through this command line tool, which is pretty great. If you want help on an additional subcommand, so let's scroll up real quick and look at boot here, because we're going to be using this one quite a bit today. Boot a new server. All right, well, Nova help boot. You get the same type of output for Nova boot. You can see that there are options such as flavor, image, etc., etc. Positional arguments, optional arguments, and you'll see what all that means in a sec. But being able to navigate this will really give you all you need to figure out the command line tools for the most part, especially once you've seen some examples. Let's look at creating key pairs now. This is super easy. When you're using OpenStack and you're booting VMs, a lot of the default images will not even have a default password enabled for security reasons. So if you don't pass a key pair to them, you're not even going to be able to authenticate remotely. So most installs should have a default key, but they may or may not, depending on what installation method you're using. Fortunately, it's extremely easy to manage these. Nova key pair list will show us the existing ones. You can see we already have a default admin key, and we can say Nova key pair add, and without specifying anything here, it's going to give us an error saying that we either need to specify a public key, so if you have an existing key that you want to import into OpenStack, you can do that, or you can create one by giving it a name. We'll call this one test key. Once you run that, it's going to output the private key. You need to make sure you copy this and save this somewhere. If you lose this, your key pair is now useless, and you might as well delete it and create a new one. We're actually not going to use this one, so I'm going to actually just ignore that. Nova key pair list. There is our new key pair. If you want to delete one, Nova key pair delete, test key. That was easy. Okay, let's go ahead and create a glance image. I'm actually going to pull one down off the internet. We have a couple in our default install that are sourced from a web location. So no, okay, there we go. So you can use Glance to import a whole variety of already created images out there. Most cloudy images will work without any alteration. We're going to use Ubuntu Precise since it's the current stable release of Ubuntu. And once this finishes downloading, we're going to go ahead and take a look at the existing images that we already have. And then we're going to create a new image based on this image we just downloaded. So let's see what we already have with Glance image list. There's actually one there earlier from when I messed up, which I'm going to delete. Let's just pretend that never happened. And now we're going to create a new one with Glance help image create. You can see when we want to create an image, there are a variety of optional arguments. You can specify an ID, otherwise it'll pick one on its own, the name of the image, what store to upload it to if you have multiple Glance image stores, disk format, container format, minimum disk and minimum RAM, so you can prevent people from trying to boot images with flavors that are too small for them. Or you can use location, which is what the two that I looked at earlier use to indicate that it's a remote image that needs to be pulled down. So let's say Glance image create, name Ubuntu. We'll make it public. It is public true, which means that any tenant can use this. The disk format is QCOW2, and you'll need to check that when you download the image. Most OpenStack images are in QCOW2. Container format is bare, which is also typical for OpenStack images. And we're just going to go ahead and redirect from there. And you can see we've created an image. So now that we've successfully created an image, let's create a flavor. You can see what we already have. Got a single default 512 meg flavor, which would actually probably be fine for our intentions today, but we're going to create a new one anyway. So Nova help flavor create. This one's kind of interesting because it's very dependent on positional arguments. You have a name, an ID, memory size in megs, disk size in gigs, and number of vCPUs. In this case, flavor create. We're going to call our image, or our flavor, 384 meg tiny instance. We're going to make it ID 2, since we already have an ID 1 above. 384 megs of RAM, 5 gigs of disk, and 1 vCPU. Bam. It's pretty easy. Let's move on to booting an actual instance. So you can see we don't have anything running right now. In order to boot, we're going to use the boot command, which I believe we already looked at the help for. Single positional argument, name of server. But we probably want to specify the flavor, the image, and a key. So let's go ahead and say Nova boot, Ubuntu test, flavor 2, image Ubuntu, key name, admin key, which if you'll remember is the default key that we saw earlier. Now if all goes well, we have an instance booting. When you run Nova list again, you can see the status. If we get it quick enough, you can see that it's still building. And if we give it just a second longer, you can see that it's active online and we have an IP address. If you want to see the details of that image, you can run nova show Ubuntu test. It's actually harder to type than you would think. That's going to output all the details of the instance. You can also run nova console log Ubuntu test and see what's going on the instance itself. See that we've got an issue with cloud init trying to do something with /temp. That should actually time out and work in a sec. But that is not our problem right now. So let's go ahead and move on to modifying an existing image. You can see we've still got this nice cloud image that we downloaded. Let's go ahead and mount it, make a modification, and create a new glance image. We can do this using... First we need to connect it as a block device. That's done. Now we need to take a look at the partition structure of that, make sure that we're mounting the right partition. In this case, pretty easy. So let's go ahead and make a directory to mount that on. And mount this partition on MNT image. CD in here. You can see we've got an Ubuntu install here. Let's go ahead and just add something to the motd. So, hello cloud. Going to append that to the header section of the motd. And we're done. Mount it. You could obviously install packages, add users, do whatever you want to do. But for the sake of this example, we're just going to make a very small change. Unmount it, and then we are going to disconnect the image. Done. So now we've got a nice modified image. Let's go ahead and create a glance image for that. We'll call it Ubuntu motd. Make this one public as well. And no, except for I messed that up. We actually want to source that from somewhere. Just going to be our precise image. Glance image list, glance image delete. Let's go ahead and delete this one right here. You can see they have the same name but a different ID. So you could reference them by ID if needed. There we go. So now let's go ahead and boot a new instance from our spiffy new image that we just created. Let's say no boot. And we'll go ahead and call this one Ubuntu motd. Flavor 2. Image, Ubuntu motd, key name, admin key, and we're also going to go ahead and pass this poll parameter, which will let you see the progress. Oh, if you actually add a second hyphen there, as the image is created. In this case, it's probably actually just going to go from 0 to 100% because it's a pretty small image. Done. Okay, and if we look really quickly, we should be able to watch the boot process here. You can see our last one's at 4.06 seconds. More stuff continuing. You can use the Horizon dashboard to get VNC access, or just a VNC client, and actually watch this. But it's pretty nice to be able to just see what's going on in the boot process or on the instance in general using that console log command. Okay, so now we have 2 instances up and running. Let's go ahead and SSH into them. I don't want to go crazy into neutron networking or network namespaces here, so I'm just going to walk you through this. We're going to get the network namespace that we're using here, copy it. We're going to say IPNetNS exec namespace SSH, and the IP is going to be Ubuntu at 172.16.0.101, and I'll show you how I get that in just a sec. Prompted for the key. It's just going to take just a sec. Cue Jeopardy theme song. Okay, there we go. It took a little while. This is kind of an all-in-one OpenStack install running on a single fairly small public cloud image, so it's not exactly the fastest. So you can see we got logged in, we got our prompt. That's about all there is to it. Let's go ahead and log back out. I knew that IP just because I've been playing with this for a while, but you can use NovaList. It'll show you what networks they're on and what IPs they have. So we're going to go ahead and log into our motd modified server, which is just 102. You notice we don't actually have to specify a password because we're using key-based authentication. The admin key is actually automatically installed in the root user's keys. Okay. We can see that the motd change did not actually work, which just goes to show that I don't understand Ubuntu's newfangled automatically updating motd. We're going to go ahead and become root so we can take a look and make sure that we actually saw that change on the image itself. Apologize for the slowness. There we go. Okay. No. Header. Oh. Ha. That was foolishness on my part. Hold on a sec here. There we go. User error. I'm actually going to not edit that out so I can take my shames like a man. I hadn't anticipated quite how slow these VMs would be. I don't remember if I provisioned with one gig or 2 gigs of RAM, but apparently running an entire OpenStack install on top of a single cloud instance is not necessarily the highest performance thing in the world. So there we go. There's our motd modification. Okay, All right, let's go ahead and delete one of these instances. Nova list, Nova delete, Ubuntu motd. You can see the task state is deleting. It should only take a sec. Done. That's how you delete a VM. You can also do something like Nova reboot, Ubuntu test. You can see the status there, it's rebooting. You can suspend and restart, whole variety of things you can do to instances, but we're going to stop there for now. Let's go ahead and move on to Keystone. Keystone is the identity management system for OpenStack. What we're going to be looking at right now is the tenants. You can see that by default we have an admin tenant and a service tenant. We're going to create a new tenant, which you could use for creating kind of a separate environment for people to work within. You can set up quotas for the tenant so that they can only provision a certain amount of processors, vCPUs, and memory. It's a great way if you have multiple projects or multiple groups of people that you want to give access to an OpenStack cluster, but you don't necessarily want them to be able to see everything that each other is doing. Using tenants is a great way to have that logical separation. So let's go ahead and create a new tenant. Keystone tenant create name dev. And there we go. We have a new tenant. If we run Keystone tenant list, you'll see we now have an additional tenant there. Now, let's take a look at users, Keystone user list. You can see we've got a whole bunch of administrative users there already. We've got an admin user and then users for a lot of the services there. We're going to take a look at users within given tenants now. So Keystone user list tenant. You can look at the admin tenant. You can see there are two users, admin and monitoring. Take a look at the dev tenant and we'll see there are no users. So let's go ahead and create some users for the dev tenant. Keystone user create name dev admin pass admin pass tenant dev. We now have an admin user. He doesn't actually have the admin role yet, so it's actually just a regular user for the time being. We'll go ahead and add the role in a sec, but first let's create a regular user who we're just going to call dev pass tenant dev. And now we can do a Keystone user list tenant dev, and we'll see we've got two users there. We should be able to do a Keystone role list right now. You can see these are all the different roles that currently exist. We can do a Keystone user role list user dev tenant dev. Oh, that might help. You can see that they're a member, and if you look at the admin user, they're going to look exactly the same right now. Oh, right. Dev admin. So we have two users. They're both members of the dev tenant, and that's all the roles that they currently have. So if we want to add admin role to the dev admin user for the dev tenant, so they can have administrative control of the tenant, we would use Keystone user role add user dev admin tenant dev role admin. And we can go ahead and rerun this user role list for the user dev admin on tenant dev, and you'll see now they have both member and admin privileges. Pretty cool. So that gives you a pretty good basis for creating, deleting instances, images, managing tenants and users within tenants. The final thing that I want to show is actually a pretty useful testing thing. I went ahead and put it in a file here because I don't remember off the top of my head how to format all this JSON. But this allows you to use curl to authenticate a user. It's a very easy way to verify if something's failing in an inscrutable manner, perhaps, and you want to see if you're actually authenticating correctly. Here's how you would do it. So there's a little JSON data structure you pass, which has the username and password within a password credentials object. Specify content type application JSON to the keystone tokens function, and we're actually going to redirect the standard error to devnull and use Python's JSON tool to make that a little bit readable. So let's go ahead and do that now. So we'll authenticate the dev user using password devpass, and you can see the authentication was successful. We can see not an admin, no roles other than the default member, and you can see the token that you get back. It tells the expiration date, and then that's the actual token, and you can use that if you're manually doing stuff with OpenStack to prove that you're authenticated and have permissions to do things. You can see the unique ID for the user, the name, etc. And if you want to see what would happen if we use an invalid password, dev passed, you can see you get a 401 unauthorized. So I think that covers most of the basics. You should have a pretty decent understanding of how to do a lot of basic OpenStack workflows at this point. Hopefully this was helpful to you.